All right, money problems. Let's see. Number one, in 3 years, investment increases from $400 to $567. Determine the effective monthly interest rate. Hint is given. Use this formula. Another hint, the monthly rate is not the yearly rate over 12. For a yearly rate of 12%, we'll take 12th root of 1.12, blah, blah. So anyways, in 3 years, an investment increases from 400 to 567. All right, so let's plug into this guy. The amount after time passes, the principal times 1 plus r to the t. I become $567. I started with 400, and it took 3 years. Okay, so what I'm doing is I'm opening up the ability to find a yearly rate. That's what I'm doing. Now, I want the monthly rate. If I want the monthly rate, 3 years is 36 months. Did you catch that? 3 years, and this is the shortest way of doing it, determine the effective monthly interest rate. 3 years is 36 months. All right, we're going to divide out the 400. I'm probably going to erase some of this text here because that would throw you off. But anyways, so I take 567, I divide it by 400, and I'm just going to leave that the way it is because I don't want to write some decimal. I don't think somebody will understand that. I don't think it's going to be a nice looking number. And I don't, well, it's actually not that bad. Okay, I'll use that. 1.4175. Why not? It stopped. If it didn't stop, I wouldn't have used it. That equals 1 plus r to the 36th power. Now, the opposite of the 36th power is the 36th root. So I take the 36th root of both sides, and that frees that up. And then I subtract 1. Now, the 36th root is the 1/36th power. I'm not trying to confuse you. I just know that you have to understand how to convert between a radical and exponential notation. I'm going to take away that 1, that's my rate of yearly interest. Sorry, monthly. If I can speak, 1.4175 to the 1/36th power, and then take away 1. And so it's 0.0097. As a percentage, that's 0.97%. And again, this was per month. Per month. All right. Next one. Let's do 4. Sarah was given a trust fund worth $250,000 at the time of her birth and has access to this trust fund when she hits 25 years. If the fund's manager has earned 6.89% interest on average each year, what will the fund be worth when she is 25? Well, actually, that's really too easy. These are all pretty easy. But anyways, I said I'd do it, so. The amount in 25 years is simply the principal, 250,000, times 1 plus this guy. Think about this, 1 plus 0.0689, 1.0689, and then we raise it to the 25th power. And Sarah's going to be wealthy. She is. That's a green flag right there. I think so. $1,322,412.47. She's wealthy. All right, I've got 6 bolded here. Bob invests $1,500 into a savings account that pays 5.95% interest compounded daily. How long will it take his investment to double? And I gave you the formula to use, okay? So if it's going to double, it's going to become 3,000. And the principal here is 1,500. And then we have 1 plus the rate of interest, 0.0595. daily, 365 days in a year. And the exponent is going to be 365 times t. I don't know what t is. The goal was to figure out how long it takes for this to happen. So that's the setup. And, believe it or not, I do kind of want you guys doing things by hand. So what we're going to do here is we're going to divide out that 1,500. It's going to give me a 2 equal to. Now let's see what that thing inside looks like. It's an ugly looking number, isn't it? I was kind of afraid of that. Anyways, we'll just keep it. It's 1.00 and a whole bunch of stuff. We're not going to round this thing because then we get off. We're not going to do it. 0163. I think I saw a 034 or 014. And that's to the 365t. Now this thing is ready to become a logarithm. Now I'm actually going to do the ln both sides technique because it's just a little simpler. It really is. The natural log of 2 is equal to, remember when we do ln's, this comes out front, 365t natural logs of that ugly looking thing right there. Now, if I want to know what t is, I have to divide out these two things that are attached through multiplication. So t is the natural log of 2 divided by 365 natural logs of 1.000163014. Now, when I actually do this in a calculator, I'm not going to use the number I wrote on a piece of paper because, believe it or not, it was actually rounded. You're only seeing so many digits of that number. I'm dividing by 365 natural logs of that. You should play along, by the way. 11.65. I guess this is years. Yes. 11.65 years because we're using the compound interest formula. All right, there you go. What else we got? Chuck has 175 to invest. Account pays 4.8% interest, compounds quarterly. When will his investment be worth $2,000, or should I do 9? Let's do 9. Your financial advisor swears he can triple your investment of 406 years. If interest is compounded monthly, what will the annual interest rate be? So if I'm going to triple it, that means after time it becomes $1,200, right? So it's 1,200 equals the principal of 400. I'm plugging this formula, 1 plus R. Don't know R. Compounded monthly, and is 12. And we have NT as an exponent, and that's a 6. Now, you don't need to use a TI-84 for that. I mean, you do, but you don't need to use a graph for this. This can be done pretty easy by hand. Let's divide out that 400. That'll give us a 3 because it was going to triple. Let's see, we have 1 plus R over 12, and the exponent is going to be 72. Now, the opposite of the 72nd power is the 72nd root. So I'm going to raise both sides to the 1/72. That frees this guy up. 2 easy moves. Subtract 1. 3 to the 1/72 minus 1 is R over 12. And then finally, multiply everything by 12. And let's see what that generates. 12 parentheses 3 to the 1/72 power, if I could talk, minus 1, 0.1845, which is ridiculously high. 0.1845 is 18.45% per year. You know, that may not seem like much to you, but say I had $20,000. In 6 years, I'd have say I had 100 grand. In 6 years, I'd have 300. It's an impressive rate of return. It really is. 10 I'm saving for y'all. Y'all need to learn change of base. You can't just watch me do it. You must know change of base. It's not optional. You must know how to do this. You have to know it. Oh, yeah, a little EOC practice. Let's do 14. Simplify the cubic root of that thing. All right, well, first off, it's a cubic root. You know, the cubic root of negative 27 is negative 3, because a negative 3 times a negative 3 times a negative 3 is, in fact, negative 27. So I'm going to put a negative 3 out here. And let's just think about some of these pieces individually. All right, let's talk about this cubic root of x to the 8th. All right, that is a cubic root of an x cubed times an x cubed times an x squared. And I can evaluate both those pieces. And I'd have an x and an x out front, which is an x squared. Talked about the cubic root of y to the 6. That's a y cubed, and those can both be evaluated. You get a y and a y squared. Now, what's it sitting over? Yeah. The state of Tennessee is not going to make it this hard on you because they pulled some things from standards. But you have 1 over the cubic root of z to the 4th, which is 1 over z times the cubic root of z. Because remember, z to the 4th is z cubed times z. And you can evaluate this and throw that out front. So we're looking at z cubic roots of z left-hand side. It's not technically right. This is not really far enough. What you're supposed to do is not have a radical in the denominator. So to fix that up, we're going to multiply the numerator and denominator by the cubic root of z squared, because that's going to give me a z cubed down low. So I'd have negative 3x squared, y squared, cubic roots of z squared up top, and down low I'd have z times the cubic root of z cubed. Now those z's, I can take the cubic root of z cubed and get a z, and then z times z is z squared. So this would be the final answer. Anywhere else but Tennessee. I feel like I ought to do one more for you just because you're so bad at math. What is the vertex form of the quadratic 4x squared minus 16x plus 12? Hey, you, vertex form is a times x minus h squared plus k, where hk is the vertex of the quadratic. We've been over this, but you forgot it. The vertex of a quadratic is located at opposite b over 2a, and then this means plug in. That's what it means. So let's just start with some simple things. This is a. A is 4. Y equals 4, parentheses. Let's find this h. H is at opposite b over 2a. So it's at a positive 16 over twice of 4, which is 2, last I checked. So x minus 2. Now to find k, we're going to plug it back in. K happens when you take that 2 and you plug it back in place. So 4 times 2 squared is going to be 16. 16 minus 32 is negative 16. And then we add 12, and I think we're at negative 4. Well, there you go. Easy peasy lemon squeezy. If you remember stuff. That's your problem. You guys don't want to remember things because you don't want to memorize them in the first place. It's the only difference between me and y'all, because I memorize it.